here we're looking at the last problem from the chapter 20 notes. So we're talking about the proportion of Americans who have experienced times where they couldn't afford medical care. So the U.S. believes that 28% of Americans have experienced times where they couldn't afford medical care. So that's our P. They conduct a study. Let's figure out how to do that. So they conduct a study of 801 Americans and find that 251 of them reported that they couldn't afford medical care at some point. So that's 801 is our N. And then 251 out of 801 is our sample proportion. Okay, so let's go ahead and just record that down there. P equals 0.28, N equals 801, and P hat, oops, that's not a hat, N equals 801, and P hat, there we go, equals 0.313. Okay, so for part A, we're just conducting a hypothesis test at the 5% significance level. So we'll go ahead and record that over here at the top as well. We see that alpha has been set for us at 0.05. So that's providing our little cutoff area. Okay, so first thing we're going to do is state the null. We believe nothing's changed. The true proportion of people who can't afford medical care is 28%, but we're wondering if it's possible that that proportion is more severe. So more severe meaning more people can't afford health care. Okay, so next we are going to check our conditions. So the conditions, the first one, it's stated that it's a simple random sample. Okay. Condition number 2, we want to see at least 10 successes, at least 10 failures, so at least 10 that haven't been able to afford, and at least 10 that have been able to afford. So we'll do 0.28 times 801, and we'll see that that's bigger than 10. And then we'll do Q, so probability of finding somebody who can afford medical care, that's going to be 0.72 times 801. And that's also greater than or equal to 10. Finally, we want to stay under 10% of the population. So our population is Americans. We only sampled 801. Do we believe that there are more than 8,010? So just kind of adding a 0 there. So 10%. Do we believe that there are more than that number? Yes, there are more than 8,000 Americans. That's a safe assumption. Okay, so that is all for the state step. So now we're moving on to the plan step. So I'll just go ahead and write that over here. This was state and plan. So for this, we're going to do a 1 proportion Z test. So we're testing hypothesis. And so if we sketch a little picture, we will see we believe the true proportion is 0.28. Okay. Since it's met the conditions, it's going to follow a normal distribution with 0.28 as the center and a standard deviation of square root 0.28 times 0.72 all over 801. That gives us our standard deviation of 0.016. 0.016 is the number you should end up with for that. And so we are looking at a p hat of 0.313. Well, when we're looking at this curve, 0.313 is all the way over here, a little more than 2 standard deviations away. Okay, that was the sample proportion we observed. I want to know how unusual was it to see a sample proportion that large or more unusual. Okay, so to do that, we calculate a z-score. The z-score is going to be 2.0625. I do not want this problem to go on for 45 minutes, so if you're having trouble coming up with the z-score or the formula, please come see me. Otherwise, I want to know how unusual was that. So how unusual was it to see something 2.6, or excuse me, 2.0625 standard deviations away. So for that, we're going to do normal CDF. I'm going to start right here at that z-score, so 2.0625, and even more unusual, so that's all the way on to 999, positive infinity, with a center of 0 and 1. So we end up with a p-value of 0.0196, or we'll just round that to 0.02. Okay, so that's our p-value. All right, so that was our do step, actually doing some calculations. Now we're ready for the conclude step. I'm ready to make my decision. And looking at that p-value, I see that it's lower than my alpha value being 0.015 over here. And so I am going to reject the null hypothesis. Because the p-value is less than alpha. Or if we can just compare that over there, 0.02 is less than 0.05. So our p-value is low, we reject, and we're able to state that we have sufficient evidence that the true proportion of Americans who haven't been able to afford healthcare is greater than 28%. That was our alternative statement. We found evidence for it. So that is the end of the hypothesis test. Okay, and that should be your longest step there for this problem. So part B says, were the results statistically significant? So yes, anytime we reject the null, that means we found statistically significant evidence, sufficient evidence. Okay, that's it for part B. Part C, so since the true proportion we're saying is greater than 28%, well, how much greater? So for that, we want to run a confidence interval. So a confidence interval has very similar conditions that we need to check. So let's go ahead and start with that. I know my p hat is 0.313. Okay, I know my n is 801. So I want to create a 92% confidence interval. So confidence level is 92%. So I just showed that that p that I previously had is not, or at least we have evidence to support that it's not actually the true proportion. So since I don't have the true proportion anymore, I need to check different conditions. So again, it's stated SRS. But now here, since I don't know that true p, I need to check n p hat greater than or equal to 10 and n q hat greater than or equal to 10. I can't use the p and q because I just said I don't believe those are the true values. So now I need to just check, okay, is 801 times is 801 times 0.313 greater than or equal to 10? And we'll see yes it is. And then I want to know, is 801 times, let's see, this would be 687? I'll confirm that. Yeah, 687. And so we see that is greater than 10 as well. And then that third statement is still just the same. We want to stay under that 10%. So yeah, I feel confident there are more than 8,010 Americans. All right, conditions are met, so now I can create the confidence interval. And so I previously did a 1 proportion z test. Now I'm going to complete a 1 proportion z interval. And so with that, I take p hat plus or minus z star times your standard error. Okay, standard error is going to be square root. We don't know the standard deviation. Standard error is, you can think of that as the standard estimate. So we're estimating the standard deviation. So I'm going to calculate via that. Z star, I need to represent a 92% confidence level. So that's where I draw my little picture. If I've got 92%, then that means this area is 4%, so we run inverse norm. I'm going to let you do that on your own. And then p hat, we have that's 0.313. So our confidence interval ends up being, once you've done all these calculations, again, not wanting to make an hour-long video here, we end up with 0.313 plus or minus 0.029. So this piece right here is our margin of error. Just as a little refresher. Okay, so we end up with an interval of 28.4% and 34.2%. So we see that the P that our original problem had stated, the report said 28% right here. That 28% fell outside of my confidence interval, so I would have rejected it here at whatever significance level this matches. Okay, so interpreting this very quickly in context, we are 92% confident, kind of an oddly specific confidence level, but that's okay. We are 92% confident that the true proportion of Americans who at some point couldn't afford healthcare is between 28.4% and 34.2%. That's our interpretation. All right, moving right along. Let's answer part D, moving back into error interpretation. So D wants us to interpret a type 1 error. Type 1 error is when I reject the null, but I should not have. So this is the proportion of Americans who can't afford health care has increased, but it actually has not. Okay, so then part E is type 2 error. So this is when I fail to reject the null, but I should have rejected the null. So this is me saying the proportion of Americans who can't afford healthcare has not increased, but it actually has increased. So I go with the null, but I should have gone with the alternative. Okay, almost done. So part F wants us to interpret power. So power is just the probability we reject when we should have rejected. So this will be the probability that we state there's an increase in Americans who can't afford health care, and there actually was an increase. Okay. And lastly, part G, interpret the p-value. So p-value interpretation is very, very important here. So coming back up to our p-value, this really should have been question B, I suppose. But the p-value we got was 0.02. So that means that seeing a sample proportion, so seeing a p-hat that is this unusual or more unusual, so any of this shaded purple area, the chances of seeing that, if this is the true center, there's only a 2% chance that we see a p-hat that unusual. So that will be what we record down here. Okay, so again, if this is true that it's 28%, the chances of us finding an 801 person sample were 251, so that was the p-hat 0.313. The chances of that happening just randomly is 2%. So that's a little too small for us to feel comfortable, which led us to reject the null. All right, that's it. Come see me if you have any more questions about this problem. Otherwise, we are moving on to chapter 21.